Hello everyone. Plan for this recording is to talk through logarithms. As we go through, remember the definition. I will refer back to it over and over and over. Remember the definition, and logarithms will, I won't say won't be hard, but they won't be, I won't say they won't be easy, but they won't be hard. They will be much more understandable if you remember what a logarithm is doing. So, first thing, the log of 16 base 4 is equal to 2. That's how I read that right there. The log of 16 base 4 is equal to 2. Or I could say the log base 4 of 16, same thing, is equal to 2. This is my base, and this is what I'm taking the log of. Okay. The answer, this is what you have to remember, the answer to a logarithm is an exponent. The answer to a logarithm is the exponent. So if you look at that problem, or that statement that says the log of 16 base 4 is 2, why? Why is a log of 16 base 4 equal to 2? Because the question that this is asking, the question that this logarithm is asking is 4 raised to what power is equal to the number you're trying to find the log of. So, let me do another one. The log of 27 base 3. I don't know what that is. So if I were to write this in exponent form, the question this is trying to answer is 3 raised to what power is equal to 27. A logarithm is simply answering the question of an exponential. 3 raised to what power is equal to 27? And the answer to that is the answer to the logarithm. Here's an example. If I asked x squared equals 25, find x, what would you do? You would take the square root. Why? Because it's answering the question, what number squared is 25? That is what a square root does. It answers the question, what number squared is equal to 25? So what does a logarithm do? It answers the question, the base raised to what power equals 27, or some other number. So what is my answer of the log of 27 base 3? 3. Why? Because 3 times 3 times 3, or 3 to the third power, is equal to 27. The answer to a logarithm is simply an exponent. It is answering the question, what exponent? Last video, we talked about inverses. Why? Because the inverse of an exponential is a logarithm, just like the inverse of a quadratic is a square root, just like the inverse of multiplication is division. 3 times what number is equal to 27? 9. Why? Because I undo the multiplication by dividing. I'm answering the question, 3 times what? A logarithm is simply an inverse of an exponential. What exponent do I need to give me the desired number? Before we go to a hard one, like the one over here, how about log base 5, let's do another easy one, of 25? 2, right? How about the log base 2 of 16? 2 raised to what power? 2 raised to what power is equal to 16? That's what question that's asking. 2 times 2 is 4, times 2 is 8, times 2 is equal to 16. So what is my answer to this one? 4. The answer to the logarithm is answering the question, the base raised to what power equals this number here. All right, just like all my other videos. Once you think you've got the hang of it, try a few. Then come back and hear the explanation. log of 6 base 36 is answering 36 raised to what power equals 6? Well, 6 squared is 36. So how do I get 36 to go backwards and be a 6? I need to square root it, right? The square root of 36 is 6. So what exponent tells me take the square root of this number? 1/2. 36 raised to the 1/2 power means the square root of 36, which is 6. All right, go to the next one. Log base 4 of 1/16. How do I make a 4 a 1/16? Well, I know 4 squared is 16, so how do I make 4 a 1/16? -2. 4 raised to the -2nd power means 1 over 4 squared, which is equal to 1/16. Think about it the other way. Try this one. 1/2 raised to what power equals 16? Well, if a negative over here, a negative made a whole number a fraction, then a negative also makes a fraction a whole number. So 2 raised to the negative x is the same thing as what we have right there. So now how do I get a 2 to be a 16? Well, I just did that before. 2 times 2 times 2 times 2 is 16. So this is going to be a -4. 1/2 raised to the -4th power is equal to 16. Why? Because 1/2 the negative means 2, and then I take 2 to the 4th, and I get 16. All right, a couple more. X squared needs to equal 25. What does x have to be? 5. So sometimes you know the base and you're looking for the answer to the logarithm. Sometimes you know the answer and you're looking for, well, what base will give me that answer? And you're back to other techniques or other types of solving like square roots and so on. All right, last one. So this says 4 raised to the 3rd power equals x. So this one doesn't even have any solving. 4 times 4 is 16 times 4 is equal to 64. So 4 raised to the 3rd power equals what number is what this question here is asking. Answer would be 64. All right, so there's some basics. Let's take it a little further. How do we graph this thing? So we've talked about what a logarithm is. Let's graph it now. So we know how to graph an exponential. And when I graphed an exponential, I plugged in values for the exponent, for x, and I solved for y. Well, in this problem, if I plug in values for x, that could be kind of difficult. So let's switch, and let's just write what is a logarithm in exponent form. It's answering the question or asking the question, 2 to what power equals x? Right? Like we just did on that whole screen on the other screen. This base raised to what y power is equal to x. Now, let's plug in values for y just like we plugged in values for x when I had 2 to the x equals y. Let's do the exact same thing. And now let's plug in values for y, like -2, -1, 0, 1, 2. When y is a -2, I have 2 to the -2nd, which is 1 over 2 squared, which is 1/4. And if you remember the pattern from the exponential, we can fill in the left-hand side or fill in for the x. Did you kind of hear how I said that? If I know the pattern from the exponential, here is my exponential, 1/4, 1/2, 1, 2, 4. Remember the video before this? Inverses. How do you find the inverse? You switch the x and the y. What is the difference between these two tables? The x and the y are switched. A logarithm is simply the inverse of an exponential, just like a quadratic and a radical square root are inverses. Okay, let's plot those points. When x is 1/4, y is a -2. When x is 1/2, y is a -1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. Let's use the same logic as we did with the exponential. If I take y and make it smaller and smaller and smaller, meaning -3, what's happening to my x's? We're cutting in half, so we get 1/8. That's an 8. -4 would be 1/16, and so on. I'll never get to x equals 0 because I will always be dividing something in half. And I get what's called an asymptote here at x equals 0. Same concept as we did with the exponentials. There is my basic logarithm graph. Your turn. Try that one. Hit pause, come back, and join us. Okay. Rewrite this into exponential form. 3 to the y equals x. Let's make a table. -2, -1, 0, 1, 2 for y values. 3 to the negative second power is 1/9, then 1/3, then 1, then 3, then 9. So I get 1/9 and -2. 1/3, then -1. 1 and 0. 3 and 1, 9 and 2. Same idea. Comes up along the y-axis. I kind of missed there, but goes through there and on out through there. That is my basic logarithm graph. It'll look just like that almost every time. Okay, what do you think that does to my graph? It adds 2 to all these y values, right? Just like it did on all the other graphs we've done up to this point. Something outside the logarithm will move it up and down. So it simply takes all of these and moves it up 2. That didn't move up 2 very good. And this moves up 2. It simply adds 2 to every single y value. This point now moves up 2, and it's right there. This point moves up 2. This point moves up 2, and so on. What does this do to my graph? I'm going to get rid of this so I have a graph that actually stays together when I graph it. So here was y equals log base 3 of x. What does that plus 2 do? Remember, stuff inside affects the x and stuff outside affects the y. Stuff inside affects the x, but it really does opposite of what I would think. And so now I don't have an asymptote at x equals 0. I now have one at x equals -2. And this graph just simply moves back 2 units. I subtract 2 from every x value. All right. Okay, that is logarithms, a basic look at them. Okay, hope that helps.